Hello everyone, welcome to Easy Physics. Now we are going to learn Snell's law. What is Snell's law? Now light is moving from one medium to another one. While it is changing the medium, it changes also its direction of motion. Now, is there a relationship between the angle of incidence, which is the angle that the incident ray is making with the normal? This is the normal. It is a perpendicular line to the boundary between the two surfaces. So there is an angle of incidence. Is there a relationship between this angle and the angle of refraction, which is the angle between the refracted ray and the normal? And is there a relationship between n1, index of refraction of the first medium, index of refraction of the second medium? So as you see, the relationship between all these four variables is n1 sine theta 1 equals n2 sine theta 2. This is known as Snell's law. So if you are given any of these three variables, you can find the fourth one. Okay, so let's solve some problems related to the Snell's law. We are going to use this formula. The first example is a beam of light traveling through air enters a medium with an index of refraction of 1.51 and goes through it at an angle of 41 degree. What is the angle of incidence? Assume this is the boundary between the two surfaces, and let's say this is the normal, and let's say this is the angle, this is the incident ray, this is the angle of incidence, and this is the refracted ray. And this angle is given 41 degrees. Okay, the light is moving from air, so this is air and it has an index of refraction of 1. Since the light is refracted, it is bending toward the normal in this case because it is moving from a low index of refraction to a high index of refraction. Okay, our formula is n1 sine theta 1 equals n2 sine theta 2. For air, n is equal to 1. Sine theta 1 equals n2 is 1.51 times sine 41. Sine 41, if you go to a trigonometric table, you are going to see that sine 31 is equal to 0.656. So then sine theta 1 will be equal to, from here, sine theta 1 will be equal to 1.51 times 0.656. So this multiplication will end up approximately 0.99. So the sine of which angle is 0.99? Again, you need to go to a trigonometric table. You are going to see that theta 1 will be equal to 82 degrees. Okay, let's move to the second example. I'm going to delete all of this. So the second example is a laser beam in air is incident on a liquid at an angle of 53 degrees with respect to the normal. Okay, let's have a boundary between two surfaces. Let's have a normal and let's have an incident ray. A laser beam, it makes 53 degrees with the normal. Here is 53 degrees. And then it is refracted, and the angle of refraction is 35 degrees. So it is moving from air where the index of refraction is equal to 1. So our formula is n1 sine theta 1 is equal to n2 sine theta 2. So n1 is 1, index of refraction of air, and then sine 53 degrees equal, and n2 is the index of refraction of the second medium times sine 35 degrees. What is sine 35 degrees? It is equal to 0.57. 0.57. Okay, so 1 times sine 53, by the way, sine 53 approximately equals to 0.80. And now 1 sine 53 is 0.8, let's say 80, equals n2 times sine 33 is 0.57. And then from here n2 is equal to 0.80 divided by 0.57, and it will result in approximately 1.4. Okay, let's move to the next question. Let me clean this one also. Okay, the third question is, an argon krypton laser puts out green light at 514 nanometers. It takes 0.4 nanoseconds to travel through 1.2 centimeter of honey. What is the index of refraction of honey? This question is not related to Snell's law, but it will be an example for the previous lesson where we learned index of refraction. So here we are asked to find the index of refraction of honey, which will be equal to C over V. Now we know the velocity of light in vacuum is 3 times 10 to the 8, but we don't know the velocity of the light in honey. So let's find first the velocity in honey. V is equal to x over t. The distance that it covers is 10.2 centimeters. Divided by the time it takes is 0.5 nanoseconds. Okay, let's change this one to meters. It will be 10.2 times 10 to the negative 2 divided by, this will be 0.5 times 10 to the negative 9. So if you do this calculation, you are going to see that you will end up 20.4 times 10 to the 7, or for better comparison it will be 2.04 times 10 to the 8 meters per second. This is the velocity of speed of light in honey. Let's go to our initial equation. This was 3 times 10 to the 8 meters per second divided by 2.04 times 10 to the 8 meters per second. As you see, when you divide these two, approximately it will be equal to 1.5. Index of refraction of honey will be approximately equal to 1.5. Okay, let's move to the next example. In the next example, a light ray is incident upon a semicircular container of water at an angle of 53 degrees. This angle is 53 degrees. The index of refraction of water is 4 over 3. Trace the path of the ray through the water and out into air. Now this is the normal, and now the light is moving from air into the water, so it means it is going to bend toward the normal. This is the refraction of the light. So then the index of refraction of water is given. Trace the path of the ray through the water and out into the air. Let's see the angle of refraction. I mean, let's find this angle. Sorry, this is normal, and let's find this angle. So the Snell's law says that n1 sine theta 1 equals n2 sine theta 2. So n1 is air 1 times sine 53 degrees will be equal to, n2 is n of the water, it is 4 over 3 times sine theta 2. So 1 times sine 53, remember it was equal to, we deleted it, it was equal to 0.80, equals 4 over 3 times sine theta 2. If you do some calculations, sine theta 2 will be equal to approximately 0.6. And again, if you go to a trigonometric table, you are going to see that sine theta 2 is equal to 37 degrees. Okay, that's it. Let's move to, okay, it is asking the movement of the refracted ray into the air. Now, when it is refracted, it comes to this point. After this point, in which direction it is going to move? Is it going to refract toward that direction? Is it going to move without a refraction, or is it going to move toward that direction? As you see, the light is entering the from air to the water, and then this is the refracted ray, but this is the center of the semicircle. That's why since this is coming along the radius, I mean along the normal, then it will move to the air without refraction. Okay. Let's look at the next example. Calculate the index of refraction of medium B. Here the light is moving from this medium to the medium B. As you see, it is refracted away from the normal. So it means that the index of refraction of B must be smaller than the index of refraction of the glass. We should calculate a value smaller than 1.5. Let's use Snell's law. Let me use another color. Again, Snell's law is n1 sine theta 1 equals n2 sine theta 2. But here, this angle is 53 degrees. It means this is 37 degrees. We need the angle that the incident ray is making with the normal. And this is 37 degrees. It means this is 53 degrees. Okay, n1, this medium, 1.5 index of refraction. Sine, the angle is 37, sine 37 degrees, equal n2, it is nb, we are asked to find it, times sine 53. Now, remember, sine 37 was 0.6. Sine 37 is 0.6, so 1.5 times 0.6 equals nb times sine 53 is 0.8. So from here, nb is going to be equal to 0.6 divided by 0.8, which is going to be 6 over 8, 3 over 4 is the index of refraction of the medium B. Okay, let's move to the next question. Okay, but I think we have made a mistake here. I need to correct here, sorry. This is 1.5 times 0.6. That's why the result is going to be something else. And if you do the calculations, this is going to be equal to 1.125. So index of refraction of B, I forgot to multiply with 1.5. Now it is going to be equal to 1.125. The last example is the light is moving from air into the water. It is going to bend. It is going to bend toward the normal. Then from water to glass, if we draw the normal again, if we draw the normal for this boundary, it is again going to refract toward the normal. So the normal is not very well drawn. Let me draw it very well, something like this. Then the refracted ray is going to bend toward the normal. Okay, so the index of refraction of glass is 1.5. Find the angle of refraction in the glass. We are going to find this angle. Now we are going to apply Snell's law 2 times. First for air water, and then for water glass. For air water, n1 is 1 index of refraction of air, and this is 40 degrees. Here is the 60 degree, the angle with the normal. So sine 60 will be equal to, this is the angle of refraction, sine theta 2 times the index of refraction of water is 4 over 3. It's not given in the question, but it is 4 over 3. It should have been given. So from this calculation, the sine 60 is sine 60 is 0.64 approximately, equals sine theta 2 times 4 over 3. And from here, if you do some calculations, some mathematics, you are going to see that sine theta 2 is going to be equal to 0.48. And this is the sine of which angle? Please go to a trigonometric table. You are going to see that it is approximately 29 degrees. So this angle is 29 degrees. This is theta 2, and it will be equal to this angle. As you see, these two lines are parallel to each other. This angle is always equal to that angle. That's why for water glass, the angle of incidence will be 29 degrees. And let's find the angle of refraction in glass. We are asked to find this angle. Okay, so n water, 4 over 3. Let me separate them. 4 over 3 times sine 4 over 3 times sine 29 degrees will be equal to n glass is 1.5 times sine theta 3. Let's say this is the theta 3. So 4 over 3 times sine 29 was equal to 0.48 in our previous calculation, equals 1.5 times sine theta 3. So from here, sine theta 3 will be equal to sine theta 3. After making some calculations, you are going to get 0.43. And this is the sine of which angle? It is the sine of 26 degrees. So light is incident from air to the water. It is refracted and it is bended toward the normal, and this angle is 29 degrees. And then once it enters from water to glass, it bends one more, and this angle is 26 degrees as expected. Why? Because if this is 29 degrees, this must be smaller than 29 degrees. That's all. Thank you for listening.